is you assess then, is this effect actually significant? Am I 95% sure that there actually is a true non-zero effect? Is there a true negative effect in this case? And there's a couple ways you can do this with output. There's very little calculation with regression. It's all just looking at the output, so your days of calculating lots of stuff by hand are already numbered. Maybe like that. That might come back, haunt you one more time in the final. But what do we look at? We want to see, is this a significant effect? Is this less than 5%, say, is this greater than 95%? That's what we're looking at. We're looking at whether this is significant. Are we sure that popularity actually has an effect on house seats lost? Or meaning, are we sure that there actually is some relationship that's actually not zero between the two, where the slope's not zero? The way you find that out, it does it for you. But go down to the last row. It takes, the regression output will take the coefficient, it will divide that by the standard error of the estimate. The coefficient divided by the standard error gives you the t. Remember, t is a lot like a z, but with a small sample size like this, the t is a little bit wider. So it's not just 1.96, you have to pass the threshold a little bit higher than 1.96, perhaps 2.3 or 2.4 or so, with whatever degrees of freedom are, don't worry about it. But notice that the way this test is done, and it'll do it for you, but the way this test is done is it takes, the way you get the t is equal to the slope divided by the standard error of the slope. Or minus 1.28 divided by 0.30, which is equal to about 4.2. Maybe next week I'll get to, where does that magical standard error of the slope come from? It basically comes from back at the unexplained part of the variation. I don't know if I want to explain to you right now, I'll explain next week. But basically it does come from how much residual there is compared to how much explained there is. And I'll show it to you next week, sort of where that number actually shows up from. But that's the t. And the nice thing is then, what does any regression output also give you? It gives you the p-value associated with that t. And what's the p-value? It's like 0.000898. So that's the probability that the null is true. It's 0.000898. Or this is 0.999 something or other. So what does that mean? Yeah. We can easily reject the null hypothesis. We can reject it. We're way more than 95% confident that popularity actually has an effect on house seats lost. Now, any regression output you read will always automatically adjust for the degrees of freedom or sample size being a little bit smaller. So in this case, the 4.2 actually, it didn't just have to pass over a threshold of 1.96, because my degrees of freedom are only, which is 14, because my observations are 16. But anyhow, it will adjust for that. But what does it also give you? It will also give you a confidence interval. And this is how confident you are in the slope. This is another important thing that goes along with the significance. So yes, as long as my p-value is below 0.05, I can say with 95% confidence that indeed this effect is true. I'm 95% confident that there's a true effect here, and I can reject the null hypothesis. Popularity has an, I'm 95% sure that popularity has an effect on house seats lost. But the other thing you can look at that sort of gives you pause and goes, oh well, is the confidence interval. And the confidence interval is how confident are you in that slope of minus 1 point, where is it? 1.28 or 1.3. But look at the 95% confidence interval. The confidence interval actually goes from, our best guess is minus 1.28. And we're 95% sure the confidence interval goes from minus 1.94 on the low side up to minus 0.62 on the high side. That's our 95% confidence interval. That's very important to understand as well. Because you might sort of, and this is where people sort of trick you with stats all the time, with integration, is the person will say, popularity of the president, you know, and it's fine, we are 99.9% sure that it matters, based on the data from post-World War II. But, notice my prediction that I made? In reality, I'm only 95% sure that the true effect of House seats lost, of popularity and House seats lost, ranges from 1.94, minus 1.94 on the low side, up to minus 0.62 on the high side. What does that mean? That means it's possible that with coming elections, that popularity will go up by 10 percentage points, and the effect might be almost 2 to 1. Meaning that 10 percentage points off of popularity, and you actually gain 20 seats. Or the effect could be, you know, on the low side of that, the high side of that rather, popularity goes up by 10 percentage points and you only gain 6 seats. So I shouldn't be too confident in my predictions, is what that